All right, so question number 16 says a 5 kilogram mass attached to a spring or a string, excuse me, of 2 meters, which is initially horizontal, and it's then released and allowed to swing in the vertical position. And we're going to look at what's the speed when we get here, what is the acceleration when we get here, draw the forces on the mass, and then find the tension in the string. So I'm just going to assume everything is down here at the bottom in the vertical position. So let's attack this. Obviously, we see circular motion as it's following here, but we need to use some other ideas as well. So first thing is we're going to find the speed at B. So we'll call this position A, and we'll call this position B. So what I see is that at A, we have gravitational potential energy as long as we take this as our height equals 0. And then at B, we have kinetic energy. So all that gravitational potential has turned into kinetic. And we know that the string has a length of 2 meters. So that's kind of my R as well as my H in terms of how high I am from when I start. So we're going to say EG equals K, and that's mass gravity times height equals 1/2 mv squared. Again, here, my masses are going to cancel out. And if I solve for V, that's simply going to be 2GH radical. So that's 2 times 10 times 2 square root. So that's a square root of 40. Which that means my velocity at the bottom is going to be about 6.3 meters per second. Okay, now part B says find the acceleration of the mass. So while here we're not speeding up anymore, we are still accelerating due to the fact that if we look at our forces, right, we would have a gravitational force down. This is actually C. Okay, let's just do C next because that just makes sense, right? So C, draw forces at the vertical position. So my mass is here. We're going to have the gravitational force, which is going to be acting downwards. And then we're going to have tension, which is upwards. And tension is going to have to be greater than the force of gravity. And that's because we need a net force that is pointing towards the center of my circle. So the sum of the forces in the y direction would be tension minus the force of gravity equals mass times acceleration centripetal, because that is a centripetal acceleration. And we'll use that in D, but now let's go back up here and find A of the mass. So because it's a centripetal acceleration, we know that's V squared over R. So that's going to be 6.3 squared divided by 2. Which is going to be 19.8 meters per second squared. Then lastly, part D just says find my tension. And so I'm going to use this equation. I'm going to use this equation here to actually find my tension. We already know the acceleration. We know my mass. We can find gravity. So tension is all we need to find. So tension is going to equal mass times acceleration centripetal plus my force of gravity. So tension equals mass acceleration centripetal plus mass times gravity. So tension is going to equal my mass times my centripetal acceleration plus little g. So plugging that in, what was my mass? 2, I believe. Yep. Nope. 5. So mass is 5. Centripetal acceleration was 19.8 plus gravity, which is 10, is is going to be my tension. So 29.8 times 5 is going to give me 149 newtons. 149 newtons, and that makes sense because remember the force of gravity is going to be 5 times 10, which is 50. And so my tension force has to be bigger than 50 because we need, again, a net force up. And really my net force then would be about 100, which makes sense because F net is simply mass times acceleration. Mass is 5, acceleration, centripetal is 20, and 20 times 5 is 100. So all those numbers make sense. So again, just a great example of how we can combine the different concepts of energy and then circular motion to be able to figure out all this information.